office. One of the fundamental difference between the way television and the internet works is that television is a one-way medium, right? Unlike the internet, we don't normally question back, or there's no way to suddenly cross-reference or Google like in the television. We just believe whatever just comes, right? So imagine if someone hacks into your cable operator's network and tries to stream in unauthorized broadcasting by, like say, some riots happening in a nearby city, and it really causes a panic. So today, we'll be talking about how to make things like what you saw just now real, right? So today, these are the technologies we'll be hacking into. We'll start with the analog cable TV, the introduction, how the technology behind that works, and how we can hack into it. And there's something else called as a digital video broadcasting conditional access technology, which is based out of the digital TV technology. And we'll see how to hack into that as well, alongside IPTV, which basically works on the IP layer. So one of the things which we won't be talking about is the satellite communication, right? So things like if you're having things like Airtel DTH in your house, or Reliance Big TV, things like that, we won't be talking about how we intercept the communication on the air, like Superman style, but we'll be talking about on-the-wire attacks and network kind of attacks, right? So a little bit about me. I work as a security engineer. I'm especially interested in web and client-side and network security stuff. I go by the Twitter handle SkepticFX and a blog at blog.skepticfx.com. So,
myself, Rahul Shashi. I work as a security engineer. I'm a speaker as well. So I got the opportunity to speak at the following conferences. I'm one of the admin members of the community Garage for Hackers. How many of you have not heard about the community? Raise your hands. Garage for Hackers. How many of you have not heard about the community? 1, 2, 3, 4. Oh, come on. So 3, that's good. So if you haven't, just come check out our post. Try to contribute to it. It's a community for like-minded people. We just share our tools, ideas, everything which is related to security over there. It's open source. So I go by the handle FP1H2S. This is my home. This is where I come from. Where we have a lot of people over from the community over here. Just interact with us. We would like to learn a lot from you. So in today's agenda, we will have an introduction to analog networks and how the architecture of the analog networks is, and how the migration from analog to digital happened. The highlight of the talk would be on digital cable TV networks, the migration from analog to TV and how it took place, the entire architecture of analog digital networks, and how it is possible to attack them. So that is the highlight. Everyone in this room have the basic idea how the cable TV transmission works, because TV was there even before any of you were born. So this is a very fundamental operation. I'm going to explain it. You have the FM modulating unit, which broadcasts the signal to the satellite. Then we have the antenna farm, which receives the signal from the satellites. And then we have something called IR, decoded integrated receiver unit, which decodes the signals which came from the satellites, from the antennas. And then we have distributed to the local cable TV networks. Remember, it's for analog networks. And then it goes to the individual TV, and the user could view the pictures, audio and sound. To explain it a little more, let me start from here. You have the satellite, you have the dish TV. It goes to the decoder unit, that is the IR decoders. Then it went through a process called quantitative amplitude modulation. The multiple signals are then amplified, because now it has to be sent across for the users across the country, in the local region, and it's distributed. So it goes over optical fiber network, and it reaches the local cable TV operator. So these are the guys that can again split it from optical to fiber and then transmit over to a home TV user. So this is the antenna farm. We need multiple of these antennas to decode signals, because let's say Star Sports, which comes from a particular satellite. India Vision or Ashgar would be coming from a different satellite. So we need to have different satellite dish TVs pointing at different satellites to receive those signals, and those signals again goes to the decoding units. So these are called the antenna farms. So this is one of the important things, the IR decoder, integrated receiver decoder. What you see on the top, the first one, it's visible on the back right? What you see in the back is the IR decoder units. And the one you see on the bottom are the modulators. So we have a modulator over here. So this is one modulator. So that is the same thing. So what happens is the signals which come from the antenna goes to these things. These are the ones which convert the FM modulator signals to analog signals. Then the analog ones go to the modulator. The modulators are the one which converts it to any desired frequency. Because your TV, your analog TV understands a frequency, and this is the one which converts it to that particular thing. And if you look at it, this is the IR decoder for national channel. National channel comes from a particular frequency, and then the modulator remodulates it and transmits it. At the cable TV operator end, if he wants, he can remodulate the national channel's frequency to any frequency he wants with the modulator. But certain channels, like this is a national channel, right? So he cannot modulate this particular frequency. But if it's some other NDTV, he can modulate it to his desired frequency. So that is a fundamental thing we have to remember. So since we are having multiple channels, we have India Vision, Sati, NDTV, Aaj so you need to have multiple of these IR decoders for each of these channels to decode each of these signals. So what you see here is an IR decoder unit. So you can see on the top you have the IR decoder, then you have the modulator down there. So first one will be for national channel, then it will be for Aaj then it will be for NDTV, then it will be for the multiple channels. So this is how it actually works. So the output of this thing goes to the QAM. So all these things have to be clubbed together, because at your home, if you switch the channel, you should be able to see the next channel. So it has to be all combined together. And the process is called converted amplitude modulation, and this is how it happens. So for researching on something like this, you need the equipment, right? The way we did it, the talk how we did it was like we approached a state cable TV operator. We approached them. We said we'll find bugs in your system. We don't have to pay us, but let us speak our research in a conference or something like that. Let us publicize our research. So for the last 6-7 months, we are working with them, finding bugs and helping them fix the things. So what all things we found, the things which they allowed to present over here, we will be talking about that. And the reason why we are in Lungi here today is because the things we learned, all the things we learned are from the field. Most of these things, there are less information on the internet, like how the functionality is. So these cable TV operators, who are the locals, who doesn't have a degree or they are not like professionals, they walk around in the lungis in these units. All those TVs, you get everything, they get it done, in the very simplicity form. So showing their appreciation of how they have collaborated with us. So that is the only reason we are here in lungis. So the QAM device, what it simply does is it does an analog plus digital modulation. It does both, so that even a home TV. So this is a digital TV. Some TVs can only display analog signals. So even the operator supports both. The TV should be able to display both of them. So that is it does both analog and digital. It simply modulates the amplitude of an analog waves using something called AM modulation. It modulates the amplitude of digital waves using amplitude shift gain, and then the waves are summed together and sent over the wire. So and the communication is optic communication. So on the optic communication. So what you see over here, this is the QAM device. The device on the top, that box is the QAM device, which clubs the signals together, which comes from all the IR decoders, sends it over the wire. The fundamental thing over here is the transmission is unencrypted because it's analog and this is how it was. There was no encryption. So let me do a recap of what I talked so far. We have multiple channels. Each channel received will be under a particular frequency, right? Cable operators could modulate them to any frequency they want. FDMA is used to send different channels to the user frequency. The transmission medium is radio over fiber. The TV channels tune into each of these frequencies. Let's say NDTV is set to channel 23 and Aaj Tak is set to channel 27. The TV knows that this frequency is set for this thing and it decodes it and then displays it over there. So that is how it works. Having known this entire architecture, let me ask you, what is the layer you can attack? As an attacker, if you want to do an analog broadcasting on an analog network, what do you think could be attacked in this picture, entire recording? Any ideas?
Decoder?
Satellite.
Satellite, we are not that. Yeah, so this region is the attacker, the cone area, because the transmission over here is unencrypted. So you can easily do an MITM attack to get, you can have either free cable television network, or you can have you broadcast your own signals like the one which you saw in the first video. So you can broadcast your own video. So the entire setup to build this thing, you need the following devices. So this is our garage. This is our unit which we run the MITM. On the top you have multiple modulators. So the things you need is an optical receiver, optical coaxial, optical to coaxial converter, which the cable operators already have, an amplifier because you need to boost the signals, a signal tap off. This is the one which taps in the signals and injects it into the thing. We really wanted to bring the entire thing over to here, but this is the entire mess we were dealing with for the last 7 months, and it's technically we had brought a couple of things. Let's see how it works. So far it's back.
So Rahul, even if you're bored, I don't think you're gonna fit it like.
Yeah, I mean this now Bangalore, where the presentation now Bangalore happens is bigger than this one, I guess. The conference has. So yeah. So anyway,
You can get this now.
yeah.
Get into the lobby.
That one is bigger than this one.
That's it. Get into the lobby.
So the local cable TV operators, like I said, till the local cable TV operator, the fiber optic is the incoming thing. And from there, because fiber optic is a little bit expensive, so from the local cable TV operator, it splits to coaxial and then they distribute it to individual users. So this is an optical receiver. What you see is an optical receiver. The optical in goes here, and so this picture gives you a better. So the optical receiver takes the optical input. The output comes through this particular board, and there you have the coaxial output. So there is the NB2, the man-in-the-middle attack. So this is a signal tapper actually. What I'm holding is a signal tapper. It's from the diagram itself, it's thing. You have a one-way thing going in, and then you can inject the signals through the other thing. So that end goes to our modulator, where we modulate the thing. So simply, if I wanted to do an unauthorized broadcasting on an analog network, all I have to do is, let's say NDTV would be on frequency A, and timestamp would be on frequency B. These signals are sent off the coaxial wire. TV knows how to decode them. So channel number 1 would be preset to display NDTV, and channel number 2 would be displayed to timestamp. So simply, if I wanted to swap the channel when NDTV is broadcasted with my own signals, all I have to do is inject the same frequency as NDTV using a modulator, modulate with the same frequency and put it on the wire. So this is the logic, this is the technical, this is a theory. Let's see how it works. So what we are going to do here is this is the unit. So what we see here is the optical input that's getting converted, and then you have the end. So you have the modulator over here. So it displays the frequency it's going to modulate to. So with this device, we are going to take a video and try to inject with the same frequency. Modulators, this part. So in the TV end, it is currently displaying a particular frequency. We will inject the same frequency on the wire. So technically, it should swap the channel and give you the unauthorized broadcasting. Let's see what happens. So in a few seconds, we are going to inject the same frequency which is displaying right now. It didn't do a swap. Any idea what is happening? Any idea which didn't work? Like over here, if you look, it didn't. It should have shown a different. The injected signals it would have shown. But see what is happening. Look closely. Yeah. So at this point, you can see. This point, you can see that it's not able to. Any idea what has happened right now? What is the logic flow which has happened? What? Oh, yes. So, yeah, it's a collision actually which is happening. So the point is, there is a collision. You have already a signal the same frequency on the wire. You're introducing the same frequency. The TV now doesn't know. It's a collision, and the TV cannot decode the signal. So that is what you're seeing. It's simply, you can create a denial of service condition, but you cannot inject the signals over here. So if you want, you can take down the entire this thing. For avoiding the collision, you can do two things. You can shut down the entire power, entire source which is coming. That will cause everyone to not receive any channels at all. Or the second thing, the thing which we used is something called as a signal cutter. What it does is, the incoming frequency of NDTV, it chops down that particular frequency, and then we inject the same frequency. So the existing frequency is not there, it's something else, and then we have injected our own frequency. And we have something like this.
Just click inside.
Okay. So this is the famous interview of Rahul Gandhi with Arthur So yeah.
With all the biggest newsmakers, we've taken straight questions from India's most direct line.
Knowledge is free and Garage Forum is to Libre knowledge. You may acquire, interpret, and apply freely the knowledge you gain from Garage. The knowledge can be reformulated according to one's needs and shared with others for community benefit. Visit us at garage4hackers.com. Have a good time and go.
So what just Rahul showed you is all analog. Still in a setup like today, where we still have a lot of people still using analog cable TV, all these things can still be done for a large mass of people. But one of the interesting things which happened really recently is that the Lok Sabha recently passed a bill in 2011 that all the cable network operators should be digitalized. That means we are moving to all digital. Things like DVB-C, IPTV, all this dish which we are having, we are supposed to move to all that according to the law. Now, and one of the blockers for people like us is that all the network all the traffic which should go on the wire should be encrypted, right? So previously we were able to take some signal, descramble it, do whatever stuff we can do. But now we cannot do that because everything is encrypted and we don't have the keys. One of the important things to note here is that if something is being encrypted on the wire and if the subscriber has to have access to it, he has to decrypt it, right? So we need a device over there, so that's what we have. Among with the other purposes, we use something called as a set-top box, right? So basically the set-top box decodes all your QAM modulated signals. So everything comes in a single line because all your channels, all your frequencies summed up together. You just need to split them accordingly. So that's what you use a QAM demodulator. The set-top box does that. And depending upon the channel that we are using, which is the digital video broadcasting or the IPTV, if it's an IPTV, you're basically going to use something like the whole traffic is going to be on top of a TCP/IP stack. So you can think of all kinds of attacks on TCP/IP and it still works. So each STB has to be uniquely identified for the given customer, right? How do we do that? If it's an IPTV, naturally MAC comes into the picture. That's how we uniquely identify some end device, right? And or if you use something like a DVB-C, or even if you're still using IPTV, you can still go for something like the smart cards, which are Airtel and PTH providers give us. So that way, we'll be able to uniquely identify each and every subscriber. So this is the one which we had in the local setup. So we're just pausing to show what exactly endpoint STB's panel looks like. So this is the UI is basically the unique identity that this subscriber has. So what does that mean to us? So if you need to have some targeted attacks, if I need to, let's say, attack or send some unauthorized broadcast to a given person, say your girlfriend or someone else's house, this is what you need, right? So, yeah, and in case of IPTV, as I said, it's going to be MAC addresses. And this is a digital TV we had, DVB-C network. So we have a normal unique identity. So,
So there are two types of set-top boxes. The DVB-C, that's a digital video broadcasting standard, and what it does is, so it's the same standard with the satellite, the digital dish TV and all those things used. It works on base of QM modulation, and these are the encryption layers supported. It is used to, this particular DVB-C set-top boxes are used to receive both audio and video signals. And then we have the second type of set-top boxes, that is for IPTV networks. Obviously, this works on top of the TCP/IP layer. The difference is this supports audio, video, and data as well. That means you can have internet connection using these set-top boxes. So you can browse through to the internet using your digital TV on these sort of networks. To give the overall architecture of these devices, let's say, so we have the source end, the management, and the home network. All right. So the source end is the one, the satellites, the IR decoders, the DRM servers, which we already discussed in our analog thing. We have the management network, which consists of the middleware servers. Middleware servers are nothing but the billing applications, the servers which stores which channels you are subscribed to, or what all packages you are taken, or have you paid the bill. If you haven't paid the bill, like they can do something. So everything comes in the management network. Then we have the home end user network, that is home network, where we have the set-top boxes which decodes these signals. To make it more clear, we have the satellites, everything in the head end. Then we have the digital, the billing server and everything over here. So you can see a billing server, video on demand server, live broadcast server. So these are the net management servers which are in this network. And then we have access switches and everything, and the home TV users, which in the very end, the third layer. So I think this architecture is clear, right? So what has happened, the analog and the digital thing, I think the difference is clear. If it is, what do you think would be attacked in this architecture? What is the easy target? I don't want to think big or anything like that. Just think in the normal perspective, which is the easy way to attack these sort of things. The signals are encrypted right now. Do you understand?
Operator.
Yeah. So I'll tell you. So the management network is one easy target. These have the applications. If you have good at application layer bugs, you can easily do everything which you want, which you did in the analog, and it can be done to the entire nation or the entire state. Second is, someone already said, the set-top boxes, the home user. If you can get a control over the set-top boxes, you can have your own firmware, or you can have your own backdoor which will display everything when asked. So today's attack, like I said, we've been working on this for the last 7 months, and the things we can discuss right now, we'll be discussing. There will be few more bugs will be coming, we'll talk about that. So we have some bugs on the application layer, bugs on the billing servers, which we will explain. We'll explain some firmware related bugs. Normally protocol level bugs in the implementation of certain things inside the firmware, the set-top boxes firmware. So having said that, the management, the middleware server provides billing and customer service. Attacks on the middleware are possible both on the DVB-C and IPTV. So most of the Indian, right now we are mostly on the DVB-C network, and this attack on the main infrastructure which works for everything. It is not like specific for IPTV or anything. So now the question is, how do I locate one of these middleware centralized management servers? The question is, like, you are already in their network. In the case of IPTV, you can easily scan your network and find them. So there are some restrictions. But yes, you can easily find the targets. In our case, we were able to find the service. Another interesting thing is these controllers are available on the internet. The same way SCADA is not supposed to be on the internet, this thing is also on the internet. The reason being, let's talk about the reason being in India, because when it was analog, like few years back, there were small operators managing these devices, and they used to have their own units. It was not very expensive. But when the government changed the policy, they have to make it digitalized. And for digitalization, there is a lot of expense involved in it. And a small operator cannot afford it. So what they have done is they have come together, all the different small operators have come together and made a association. So now the association builds the entire infrastructure for them and leases out it for the cable operators. So that means if they need to have an administrative panel, it has to be online. And if you know the process, a simple query can itself reveal you where the panel is. So this is one control panel of a video, actually one of the biggest of the thing. How we got in is not something we're going to explain today. Like I said, we've been working with them. This is fixed with them, but then there are a lot of other service providers which are using the same setup and it's portable. So the remote code execution part we would not be explaining, but a couple of other things would be explained. So over here you can see those are the list of customers. So these are the list of individual setup boxes. So this is the address of the user. This is the unique ID. And over here if you see these buttons, this button can actually remotely shut down your cable signals actually. And this particular thing, the operator can add a particular service. So if you are not subscribed to NDTV, I can add the subscription using this button. So the point is there are so many features in this management layer which can be abused if you can either get access to one of them or if you find some of the bugs.
So now that we know about the middleware servers and how the entire architecture of how the IPTV and DVB looks like, let's talk about a couple of bugs that we used. So these are majorly web application attacks, and so the things that you're talking about will be more technically web oriented. So don't expect anything from a cable operator perspective, but how we can leverage that, or how can we leverage all the daily bugs that we see for the maximum benefit of ours. So talking about the STB hijack attack, so let's talk about one of the important features these STB operators have, the cable operators have. So let's say that I am in Bangalore today and tomorrow I want to move to Mumbai. I take my set-top box with me, right? And I tell my operator, hey, look, I'm moving my set-top box, changing my location, I just want your connection over in Mumbai. Now what happens here is that all the operators are interconnected, right? If you're in the same cable network operator head, they're all going to be in problem. So so what happens here is a challenge response protocol between themselves. So the operator in Mumbai is going to tell the operator in Bangalore, so what you have to do is, this is the customer ID, and you have to just have this access code put in our server so that it just automatically transfers all the configuration for the given user. Now this is a very powerful feature, and it's being used widely because people really need that. This is a very common use case. People move from here and there, and this is fundamentally important. So if you look at it, if we have the access key, what does that mean? It means that I can basically transfer anyone's operator to mine. So if I have a cable network on my own, if I being an operator, I can take over an entire city to myself.
So technically speaking, so I have a local access on one of the panels of the normal cable operator, which he is in Goa. I can now transfer the entire Bangalore to me, and then I can do all those shutting down things or whatever I want, or all those things.
So here's the server-side snippet of the actual bug. I'm pretty sure some of you must be already aware of it, what's going on here. So I'll give you a few seconds. Could you just guess what's happening here, what the bug might be?
But what an XKCMP?
It's a string comparing PHP.
It should be triple equal to.
So if you pass an array
Yeah.
to that get key, so it will always return true.
But okay, that is right.
Okay, so STRCMP is one of the culprits there. So basically, what's happening here is for us to completely bypass this, we just need to make sure that this if statement over here returns true. So to do that, let's trace back. There's an strcmp, a string compare in PHP, which does a comparison of two strings, which is the API key, which is the secret one, and the other one is the user provided one, the one which we have access to. So in PHP's strcmp, according to the specification itself, if you pass an array to it, it's going to return you null. Right?
Along
Now,
with the warning.
yeah. So what the authenticated variable is going to have is a value null. Now, here's another interesting thing. So if you're from the C world or the strongly typed world programming language, you'll notice this looks cool, the double equal to. But unfortunately, in languages like JavaScript and PHP, for strict comparison, you have to go for the triple equal to, right? So what happens here is authenticated is going to have null, and the right-hand operator is going to be 0. So it loosely says, okay, null and 0, I'm good to go. Just get in. So that's what happened here. So if you're a developer, the thing you need to notice is understand the specifications. STRCMP in itself is not the culprit here, but actually the double equal to is the culprit, right? So now what we could have done is we took one of the users and enumerated him, transferred it to us, and since these user access keys are sequential for a given region, we could just go through them, all of them, and then if you can write a script, you can take on an entire city. That can be pretty serious. So the second one is the cable TV remote shutdown. So if you know someone else's user access key, how do you basically shut them down? If I just go to Amon's house once, I kind of take a look at his UID, and next time when there's an important football match, if he's a football fan, I just try to make sure to shut down his TV. That would be pretty bad if you're a football fan.
Let's say when Sachin is no more playing, but if he was playing and I want to shut down the entire local network, how much of a problem would that be?
People living without God for some time. Some people. So yeah. So this is actually a client-side bug. So basically, to leverage this attack, we would have to do this from a cross-domain website like attacker.com, things like that. So let's see what the original thing is. So there is an API key or some kind of an access key similar to the one we saw at the beginning. But this time, the access key is embedded in a JavaScript file, and it's being used for a given operator who is logged in. So if I'm operator A and I'm logged in, I'm going to get some cookies, and along with it, whenever the secret JavaScript file loads, the load secrets.js, which is of course a static URL, but it ultimately has some dynamic content inside it, which is the access key specific to the user, right? So if I simply go and say a curl of load secret.js, I'm not going to get the access key which would be valuable. So I need the user to be logged in so that I can get a proper, useful API key.
Simply the browser cross-domain policies will not let you do that by default. So that means the attack would be like, if I'm going to force an administrator to visit my own pages, we'll talk about the thing, then he would not, by default this attack would not be able to steal the API key.
Yeah.
But
So, when you talk about this, you can think that why can't someone else load it cross-domain and steal it? But that is not happening because he has a check for that. So he basically, the developer tries to get the current URL and he does a URL.match. So in JavaScript, it's a string.match. And he compares it and it returns an array if it's equal to. So here we are assuming it's flappybirds.com. By the way, Flappy Birds, who doesn't know Flappy Birds? Alright. So it just returns true. So depending upon what your check URL returns, we are going to get into the API key. Now, this is a cross-domain hijacking attack. So what we can do is we can anyway load script src load secret.js, but as you said, you cannot steal them because the same origin policy stops you from doing that. So initially, you can do some. JavaScript is so powerful that you can basically go and say string.prototype.match, which is the global function for strings match function. And if you override that, it will override all the subsequent usage of .match. So the real .match happens in this, which basically uses ours. So regardless of what check you are going to do, we are always going to return flappybirds.com because the real actual string match doesn't happen. So this
works on all the browsers, right?
Yeah. So basically that's a fundamental way in which JavaScript can be used for your good. And this also shows about how that bug can still be used for real attacks.
So here you can see, so this is the same bug. The thing is, like, the operator, if he visits one of the malicious pages, he can shut down. We'll forcefully make him shut down. So this is one of the operators is logged into the panels. Yeah, the video is not good, but yeah.
Yeah,
So Nafis would be the things which we mentioned, the bugs which we mentioned. Nafis would be talking this in his Black Hat Asia talk next after 2 months. So you can expect more of these sort of bugs over there. Let's go to the video back. So in few minutes, the signal is this setup box would be shut down. So that. Yeah. So this is the screen we can broadcast. So you would not have any more, all of a sudden Sachin strike a 6 and then let's go. So, I'll tell you a simple story of the bug. So the first bug we found when we were discussing with the cable operator, the first bug we found, we can hijack any other cable operators from the first row. So when they fixed it, they were like, no, now this is fixed, find another one. So this was the thing which we found. So the thing is, like, they have a cable operators forum where the cable operators discuss their issues regarding all those things. All you have to do is register, post this link over there, and the entire nation will go off like this. And they have to manually go click each of these things to bring them back online, and that's going to be like very huge thing. So yeah. So another bug which we will be talking about is the STB firmware update bug. So what happens is every time the setup box load starts, it checks a middleware server to see whether an update is available or not. If it's available, it downloads it, installs it, and restarts with the new firmware. So the download happens over TFTP. So I'll show you a video of how the. So this is the setup of starting up. We are planning to do this thing over here, but then we have a problem with the cable. So this is a local operator. 1 minute. So this operator is in Manipal, which is yeah. So we go. Yeah. So the logo starts with the cable TV operator's main thing. They are in Manipal. So now, as soon as it starts, what is written over there is please wait. At this particular point of time, it's fetching the middleware server for an update. So the response pattern is auto update phase. I mean, it didn't work because there was no update available. And then, if there was an update available, you can actually go through all the functionalities and watch the TV. That's how it starts up. So technically, there are two ways to attack it. If you have control over the middleware server, what you can do is push an update to all the setup boxes. Having said that, like we had access to the middleware server, there is an option to just push a particular library. You don't have to push the entire firmware because that's going to take time. You can push a particular library which will get installed. So this option you can see is we are actually updating the firmware remotely with a particular library. We'll go into that. So there was another easy to do bug that was in the IPTV implementation of the thing. That means every IPTV setup boxes has got a telnet for remote management.
Wow.
Yeah, so it runs on Linux. The base is Linux and it's got telnet by default enabled. By reversing, so you don't need to be like geeky or this, simply reverse the thing and you'll be able to find the hard-coded password. That's with everything because there is no other way to put a telnet password. And there was a mechanism where you can issue a command, TFTP command, which says say firmware from TFTP attacker control server upgrade to that's the directory where it's going to download it to. Once you issue this command, oh yeah, by the way, the password was, the name of the people who build the setup box. It is their name in your remote. You can see like there would be ABCD keys actually. So it will be KOSHIP. So that was the password of their device. So same way, if you log in, you can actually log into any number of devices and then issue one of these, and you can actually upgrade the firmware. So kind of getting over with time. Uh, so we'll show you how a backdoor firmware is. So in the simple demonstration for the purpose, what we have done is, you see the initial operator logo which started up. So that's like inside the live CD, the CD, that's the same image. You just replace it with something else. And so there is no signing of the firmware or anything which is happening. It's like a box which is sold for 1,200, so nothing of those things happen. Simply replace that thing with anything of you want, push it to the end, and then you can make them have this. So this is how our firmware is starting up. So I simply replace that particular thing with our own custom thing. So you can make this thing happen. So